Hello friends, this is Priyanka. Today we are going to solve a problem on economic analysis of power plant. In this video, we are going to find out what is the load at which efficiency of the plant is maximum. We are also going to calculate the increase in input required to increase the output by using two methods. First method is from a given input-output curve and second method is incremental rate curve. Now first I will read what is the given problem. An input-output curve of 10 megawatt power station is given by an equation I is equal to 5 into 10 raised to 6 in bracket 18 plus 12L plus 0.5 L square, where I is in kilojoule per hour and L is the load on the power plant in megawatt. Find first the load at which efficiency of the plant will be maximum. Second, the increase in input required to increase the station output from 5 megawatt to 7 megawatt by using input-output equation and by incremental rate curve. So this was the given question. Let us first understand what is the given data. So capacity of the plant 10 megawatt and input output curve is given I is equal to 5 into 10 raised to 6 in bracket 18 plus 12 L plus 0.5 L square. So for this I is given in kilojoule per hour and L is given in megawatt. Now we will move for the first question. So what is the first question? We have to find out the load at which efficiency of the plant is maximum. So let us first write what is this efficiency. So efficiency is nothing but ratio of output to input. So here neta is equal to output divided by input. So what is output? Output is L and input is I. So L by I. So I will write the value of I in terms of L as per the given data. So I will write L divided by 5 into 10 raised to 6, 18 plus 12 L plus 0.5 L square. Now we will simplify this. So in denominator and numerator there is L. So I will divide to both numerator and denominator with L. So L by L is 1 divided by. Now here 5 into 10 raised to 6 as it is. Now in this bracket we will divide here with L. So it will become 18 by L plus 12 plus 0.5 L. Now what is the condition? We have to maintain efficiency maximum. So for this maximum efficiency we have to keep this denominator minimum. That is, to maintain this maximum efficiency our denominator should be minimum. That means here what is the value, variable value? That is the value of L, that is load. So we have to find out this value of L for which efficiency will be maximum. So for that value of denominator should be minimum, and how to find out the minimum value for this equation? So we will differentiate this equation with respect to L and we will equate it to 0. So for minimum value of 18 by L plus 12 plus 0.5 L, what we have to do? We have to differentiate this equation with respect to L and we have to equate it to 0. So I will write d by dl of 18 by L plus 12 plus 0.5 L bracket complete, which is equal to 0. So at this condition we can maintain the minimum denominator. So this is the condition for this minimum value. So if I differentiate this, so 1 upon L. So what is the differentiation? That is minus 1 by L square. So minus 1 by L square. So 18 we will write as it is. Plus, now here d by dl of 12. 12 is constant, so it is 0. And d by dl of 0.5 L. So d by dl of 0.5 L, that means it is 0.5, which is equal to 0. Now again we will simplify this and we will find out the value of L. So if I write therefore minus 18 by L square, which is equal to minus 0.5. So this minus is getting cancelled. and therefore L square is equal to 18 divided by 0.5. So if I write this 18 divided by 0.5, that is 36, which is equal to 36, and therefore L is equal to 6. So this load value is nothing but L is equal to 6, that is we get, and where this load is in megawatt. So we will write here this unit is in megawatt. Now we will convert this into kilowatt. So how to write this in kilowatt? That is 6000 kilowatt. We have to calculate the efficiency at this load. At L is equal to 6 megawatt load, efficiency will be maximum. And now how to find out the value for this maximum efficiency? Now if we observe for this load L, the value is given in megawatt, and for this I, it is in kilojoule per hour. So to calculate efficiency, we have to maintain this unit, because efficiency is having no any unit. So we have to take this numerator and denominator, that is the value of L and I, in the form of same unit. So here I is in kilojoule per hour. So we will convert this kilowatt into kilojoule per hour. So how to convert? Now what is the meaning of kilowatt? That is kilojoule, joule per second, that is nothing but watt. So how I can write this value? So I can write this kilowatt in the form of kilojoule, that is 6000 kilojoule per second, because we know that joule per second is nothing but watt. So kilojoule per second, that is equal to kilowatt. But what is the value of I? So I is in kilojoule per hour. So we will convert this into kilojoule per hour. So how to convert this? Because in 1 hour there are total how many seconds are there? That is 60 multiplied by 60, that is 3600 seconds are there. So to maintain this value kilojoule per hour, we have to multiply this, because S is in the denominator. We have to multiply here with 3600. So which is equal to 6000 into 3600 kilojoule per hour. Now we will calculate the value of I at load L is equal to 6 megawatt. So we will put here L is equal to 6 and we will find out the value. So I is equal to 5 into 108 into 10 raised to 6. And what is the unit? So as per it is given in kilojoule per hour. Now if we observe here, I is input is having unit kilojoule per hour and L is output is having unit kilojoule per hour. So we will put these values in the formula for efficiency, that is L by I, and we will calculate the efficiency. So which is equal to 0.04. So how to convert this into percentage? We will multiply with 100 and which is equal to 4%. Now we will move for the second question. Here we have to find out what is the increase in input required to increase the output from 5 megawatt to 7 megawatt. So this question we have to use two methods. So first method is input output curve and second method is incremental rate curve. So we will first take the input output curve method. So input output curve method, that means from this given input output curve equation we have to find out the increase in input. Now here increase in output is from 5 megawatt to 7 megawatt. So this is the value of load L. So here when we take L is equal to 5 megawatt, then what is the value of input? So from this equation we can calculate. So we will consider here I to the base 5, that is suffix 5 is used for the load. So I5 at L is equal to 5 megawatt. So when we put L is equal to 5 here, then we will get the value of I, and that is equal to 90.5 into 5 into 10 raised to 6. And what is the unit? It is given in kilojoule per hour. Now in the same way we will put value of I is equal to 7 megawatt and then we will find out the value, that is I7. So when we put here the value of L, that is 7. So instead of L square we will write here as a 49. Then we will get the answer 126.5 into 5 into 10 raised to 6 and unit is kilojoule per hour. Then what is the increase in input per hour? So increase in input per hour, that is the difference in between this, that is I7 minus I5. So when we take this difference, we will take 5 into 10 raised to 6 as a common. So 126 minus 90.5, that is 36 into 5 into 10 raised to 6 and unit is kilojoule per hour. So this is the answer by using the first method. Now we will move for the second method, that is the incremental rate curve method. So if we observe the graph for this incremental rate curve, then here is this curve and here is the output or load on this horizontal line that is shown, and here the vertical line shows the incremental rate. So here output or load here varies from 5 megawatt to 7 megawatt. So I will take here this first point is at L is equal to 5 and the second point is at L is equal to 7. So for these two loads, if we observe, this is the whole section I have shown with these lines, that is this load varies from 5 megawatt to 7 megawatt and here is the curve that I have shown. Now we will move for the calculation part. So what is this incremental rate? So first we will understand the definition. That is the increase in input with unit increase in output. So unit, that means 1. So whenever there is the unit increase in output, then the value of increase in input is shown with incremental rate. And what is the formula? So incremental rate IR is equal to DI by DL. Now if we observe here, the value of I is given in terms of L. So we will write this value, that is D by DL of 5 into 10 raised to 6, 18 plus 12L plus 0.5 L square. So 5 into 10 raised to 6 I will take as an outside. Then D by DL of this equation. So 18 is constant, so it is 0 plus 12L. So it is 12 plus 0.5 L square. So what is the differentiation of this L square? That is 2L. So 0.5 into 2, that is 1 and here is L. So IR is equal to 5 into 10 raised to 6 in the bracket 12 plus L. Now to calculate this incremental rate, what is the value of L that we have to consider? So if we observe here, this value of L is given, that will vary from 5 to 7 megawatt. So if we consider this curve as a straight line, then what will happen if we consider this curve, incremental rate curve, in between this 5 to 7 is a straight line, then the value of L is equal to 5 plus 7 divided by 2. That means we have to consider the average, or we have to take the average. So 5 plus 7 by 2, that is equal to 12 by 2, so which is equal to 6 megawatt. So when I put this value L is equal to 6 megawatt, then I will get the value of IR. So IR is equal to 5 into 10 raised to 6 into 12 plus 6. So which is equal to 18 multiplied by 5 into 10 raised to 6. So this calculated value of IR, as per the definition, this is the value for unit increase in output. So here is the formula, IR is equal to DI by DL. So here what is the value of DL? That is load varies from 5 to 7. So we have to take the difference for this, that is 7 minus 5. So when I put the value of IR and value of DL in this equation, then I will get value of IR is 18 into 5 into 10 raised to 6, which is equal to DI divided by, I will take this difference, that is 7 minus 5. So when we solve this, we will get the answer, that is here 7 minus 5, that is 2. So DI is equal to 36 into 5 into 10 raised to 6. And what is the unit? So unit we have to take as per this kilojoule per hour.